And now, our very special speaker for today, Brian Vermeer. He's a well-known developer advocate from Snyk, and he's also a Java champion, a software engineer with over a decade of hands-on experience. He's also the JUG leader for the Virtual JUG and NL Netherlands, very, very vibrant community, the JUG community in Netherlands, and a co-leader of the DevSecCon community and a community manager for Foojay. He's also an international speaker at many Java conferences, and that's how I met Brian at JavaOne, Co1, Devoxx, JavaZone, Devnexus, you name it, he's there. He's also interesting, and as I found out, Brian, you're also a military reserve for the Royal Netherlands Air Force and a Taekwondo Master and teacher. So welcome, Brian, and the stage is all yours, and I will stop sharing mine. Okay.
All right, now I will need to do the hardest part in the sharing my screen. That is, nowadays, it's not just plugging in your HDMI, but selecting the right screen on your desktop. And hopefully you now see a nice purple background with my Stranger Danger title on it. So thank you, Mary, for having me. Thank you, CJUG, for having me. And well, let's get going, because I will present today a security topic. And I'm hoping that you stay with me. I know that it's your noon, so it's probably your lunchtime, and I totally get it if you're after this you're having that after dinner kind of laid back. But just watch me, bear with me. I will do some life hacks. But first, before we do the life hacking, interesting stuff. I have to talk about this word, DevSecOps, and as interesting as this might sound, the first time I saw this word, it felt to me like, hey, this is yet another buzzword. Like, just put blockchain and machine learning in the mix and we have full buzzword bingo cards on the job, but it is not. Let's get to the essence of DevSecOps. First, let's get into DevOps, because I believe that a lot of us are doing DevOps or trying to do DevOps. Well, let's figure it out this way. If you think, or if you and your team are developing software and say something goes wrong, and in the end, they will call you or your team to fix it and redeploy it or something like that, then you're doing DevOps. Basically, you create it and you own it. It's not throwing your stuff over the wall again and the ops team will take care of it. No, now you are there, you're responsible for it, and you need to take responsibility for it when things go wrong as well. It's not, I build it, you fix it. No, eat your own dog food. However, within DevOps, we care about scalability, maintainability, your reusability, but security is not so much in our mindset yet. Therefore, they created DevSecOps. Well, basically, I think we have to scratch that stack out again, because I believe it's part of both the developer organization and the operations organization. We tear down that wall to make ourselves, or create better, faster, and stronger software, but we need to take care of security as well. Security is also something that both the dev organization and the ops organization should take care of. However, it is not always the case. But let's talk about that later. This is me. You already had the presentation, who I am, what I do. Not really important. I do some stuff in the community, which is interesting. But yeah, this is me. And you can follow me on Twitter. If you have questions afterwards, for instance, feel free to ping me. But with that DevSecOps, what are we trying to solve? I mean, it is something, so you're trying to solve a problem, right? However, what is the problem? Let me take you on a personal journey, and that journey goes back, say, a decade ago or something. One of my first jobs, I'm based in the Netherlands, so I live like an hour south of Amsterdam. And one of my first jobs was, I worked for a government agency. And what happened is, if you work for a government agency, things go slow. And at that point in time, we delivered, or we went to production, say, about 3 times a year. That means that creating software was done in batches, and after so many sprints, or if you can call it sprints, there was a release sprint where we created basically a release, tested everything again, and made sure that it's okay for production together with the ops team. However, if you fast forward to today, and specifically in e-commerce or something, you speed up these things. You want to maybe deliver 3 times a day instead of 3 times a year. However, I worked in these companies as well, and have these folks, like these program managers, breathing down my neck and saying, "We need this thing today." Well, actually, yesterday, and that's for a good reason, because if I have this feature out earlier than my competitors, we might have an advantage. However, that means that we cut corners, or we create technical debt, or, well, altogether, it means that we try to speed up things, we cut corners, and security is not yet the first thing that we think of. Because there's a lack of security focus all through our application lifecycle. Most of the things is like we're building things, we're testing things on a functional level, or on a feature level, and that is what we're based on, getting that feature out. Having these tests is all right, and maybe at the end there is some automated thing that does something. Nobody knows why, but if it's green, let's push it to production. And what we found out is that although we like that DevOps mindset that, hey, own what you create, in many cases, the security team or the security expertise is quite siloed at the end. So that means that after 3 weeks of working hard on my new feature, some security person comes to me and says, "Nope, we cannot go to production because we found something, or our scanner found something." I'm like, not again. There goes my bonus. Point is, there is friction between the security folks and the development folks. That's not what we want, because if there's friction, it's like, "Oh no, it's your fault. Oh no, you don't understand us." Like, you get these discussions, but in the end, we still need to play along. It's just like children on the playground. We need to make sure that we play along, because we need to take care of our customer data, and our customer data is not something we want to get compromised. Well, we recently, from Snyk, released the JVM report, the JVM Ecosystem Report 2021. And, well, probably no surprise, one of the major things people use is Spring, or more specifically, Spring Boot. So everybody probably knows this interface, the Spring Boot Initializer. Let's take that as our first way of going into our applications. Normally, what you do if you have a greenfield application and you like Spring, you're going to the initializer, you click something you want, like I want a Maven project with Java 11 or Java 16, give it a few names, and basically drag in the dependencies that you want. From that point on, you generate something, and it works. That's amazing. Like back in the old days, it was far worse to get the initial thing working. What happens is that this thing scaffolds an application for you, and then you basically end up with this. You have your application code, and this is generated for you, and it runs. Nothing you have to do. Dependencies are created, or at least your manifest file, your POM file, or a grader file is created with whatever you need for your first things that you want to create. The whole plumbing is created, and it just runs. Cool. And that is the code that we see, that we use, that we feel, and that we know. However, as you can see from the icon on the left-hand side, this is just the tip of the iceberg. Because now we have a running application and we start to create our first feature. Let's create an endpoint, or let's create an endpoint that gives me an HTML page, for instance, and I don't want to use any styling frameworks or any templating framework. So I created this. Okay, cool. Well, it works. I have my functional tests around it. But then again, there's an issue with this thing, because if you can see this clearly, there is a security issue in this code. And this might be obvious or not, doesn't matter. But let me enlarge this for you so you can actually better see this. What I'm doing, I'm having a controller, my controller, and it has a get mapping to /hello. It takes in a request parameter, a string user, and a servlet response. And what I do, I write plain HTML back to the responses writer. The problem is, if I do it this way, it perfectly works, and my functional test will pass. However, this is a classic example of cross-site scripting, because I'm taking in a user, and without doing any checks whatsoever, without doing any sanitization, I print it out. And what does that mean? If you're not familiar with cross-site scripting, this is just a basic example. There are far more advanced examples, but just to get the grip on it, think, for instance, what you do is you normally go to /hello, and then you give the user parameter as a CJUG or Mary or Brian or whatever it is, and it says, hello, CJUG. But if I give the user and do something like this, what happens? At this point, it happens that I insert a script, it doesn't get checked, and it says hello, but instead of printing something out, it gives a JavaScript alert. And this is a one-on-one example, like the easiest example that you can get. However, don't think that just fixing out the script tag will help you, because there are more of these things. For instance, we can do, like, the script is one thing, but we can do a mouse over and a click me. We can do an image and an on error, for instance, or the image source we can use to include JavaScript. What happens is we didn't sanitize our input. And this is just our code. Again, tip of the iceberg. Well, let's go to my IDE. And let's go to, which controller was it? The user controller. And basically over here is what happens, right? I'm just showing you what happens over here. And you see that over here is basically the same thing. I have a string parameter and I print this parameter out over here. Well, let me just run this application just to show you that I'm not just making things up. It actually is this way. Oh, now I'm running a test. That is not a good idea, running the test. Let me run the demo application. Point that I want to make is, maybe you are able to see this with a blind eye, or if you doing code reviews or something like that. But then again, how many of the folks that do code reviews are actually looking at the code from a security perspective? A lot of the code reviews are done on styling, or hey, this is not conform any of the things that we agreed upon, or maybe this is not efficient enough. However, maybe this one can be caught by the naked eye. But for many people that do code reviews, it's just like, yes, it works, I don't see anything weird, well, let's continue. However, going to the application and going to my localhost 8080, this is the wrong one. Well, let's just forget that. We will see that this actually is a problem. But how can we fix this? Well, for instance, I have a code scanner over here that does code scanning to see if there are vulnerabilities. Of course, I'm using the code scanner from my company, but there are multiple tools to do this. But including this in your application already can help you fix it while you create this. For instance, if I look at this user controller, it says over here, I'm having a scripting issue. So it fixes this thing, and it says in the user controller, line 35, I'm implementing parameter. And let me just show you over here that, oh, yes, that it's actually saying, hey, it starts in line 35 and it ends in line 38. So basically it helps me finding these issues and to some extent give me already the way to remediate this. By instance, for using the string escape utils and escape HTML. And this is an easy fix. But what about the next one? I mean, I have also an issue in my file controller. Now let me go to my file controller. And over here, my tool says, like on line 67, we have a path reversal issue. Okay, let me take a look. So for instance, what it says is on this line, you say you insert a multi-part file. And at the end, at line 67, we basically store this file. And we just take the file.get original file name. We upload it in our upload folder. Only the problem is there is a path reversal issue. And what is a path reversal issue? Path reversal issue is more or less what we say is if the path or if the original file name is something like ///////. We're going backwards into the path where we actually want this to be, and we can put this file into an arbitrary place on the machine that we actually don't want it to be. And this means we are able to maybe overwrite certain files that, well, might be crucial for our application. And the point is, this is a multi-part file. And if I do a curl request, somewhere this curl request will get translated to the multi-part file object. I created a unit test for this to show you that it's actually happened. If I just recreate the multipart file and not just the plain curl request, because that is, well, quite hard to read. But say I make this hello CJUG and do a path reversal over here. I'll just do it two times. Hi, CJUG. And let me just run this test. So if I run this test, then we go to that upload function that I showed you. And of course, the test passes. But the point is, where is the actual file? Well, let's go into my terminal to show you where the actual file is. This is my code workshop. And if I look over here, I'm not seeing the file. But if I go one place back, and I do an ls over here, we probably find out that the thing I just created is not actually in the path anymore where my project is, but is somewhere else on my machine. So this is an actual problem, and I didn't find this out by hand because I was like, fair, this could be, this sounds good to me. Luckily, there are tools that can save us for your own code. But again, as I started with this example, the point is, this is just the beginning, or this is just the tip of the iceberg. This is your code, and this is just a tiny little bit of the application that you actually put into production. Under the surface of this iceberg, well, here you see some of these tooling that I just showed you. Under the surface of the iceberg, there is a lot more. And one of the things that you need to take care of, for instance, are your open source dependencies. Think about it. How many dependencies do you pull into your application? If you create a Spring Boot application with just, say, only Spring MVC or Spring MVC Web, think about how many packages do you actually pull or actually put into your executable jar, and how many lines of code is that? Well, let's look at that. This is just my controller. It's just my controller, my microcontroller says, hello. But that is just the code I wrote. It's basically 4 lines of code with an annotation. But this is the jar it's in. The rest of the jar is filled up with all kinds of packages and frameworks that I use to get my code running and to do the things that I want to do. And that's for a good reason. I mean, we get these dependencies in to make sure that we're not doing the heavy lifting all over again. Honestly, I don't want to create yet another CRUD repository. If there is something that can help me with that, fine, because we get paid to do what makes a difference for a company, and that's the business logic. But how bad is that situation? Well, maybe you've heard of this company, and most of you are from Chicago, so you are located in the US. If I ask this question in Europe, it's pretty different, but you have probably heard of this company. For those who don't know, Equifax, a company based in Atlanta, and I'm not going into the company, but they do something with crediting score, they told me. However, they built their business logic on top of, well, how do I say it? An outdated version of Apache Struts back in 2017. So it was a couple of years ago. The point was that version of Apache Struts was vulnerable, but they were not aware. I assume they were focusing, like any other company, on getting new features out and not paying attention to what was already in production. However, if you're not aware of that and you didn't test it because this is part of the framework, not part of the business logic, people can get into your application, snoop around for weeks, maybe months, and find out what's happening over there. Well, it ended with over 140 million US customers were compromised and their data was out on the streets. Let's get into that hack right away. And this is not something that is in the code of the developers of that created this stuff. No, this is part of their packages of dependencies. And we know that a framework brings in a library, brings in another library, brings in another library, and it goes several layers deep. But let's go into the problem. So I have an application over here, and it runs on Heroku, and hopefully it's still running. probably needs to start up again, but it's not a big deal. And this application runs in the cloud, but actually has the same Apache Struts version that Equifax was using at that point in time. So what do? I'm not going into the application at all in the browser. No, what I do is I go to my terminal. And let's just quit this one. Let's quit this one. Cool. Yes. And let's see what's over here. There's my struts header. That's what I need. So let's go into the exploit header. What I can do is I can create a application. Well, let me just do it again over here. I can create a curl request using a specific header that triggers the vulnerability, and it's this header. Now, let me enlarge this a little bit more. And as you can see, this header contains the content type. And this content type is interesting. This content type is, well, maybe not what you've expected. This content type is invalid. And what does that mean? Well, in some way or for some reason, in this specific version of Apache Struts or Apache Struts 2, we were allowed, or you were allowed to utilize in that exceptional flow where you're going to, because it's an invalid content type, you're allowed to utilize OGNL, the Object Graph Navigational Language, which is an expression language in Apache Struts. With that expression language, you're allowed to interfere with things that are already in memory. You can set certain, you can call certain methods, like setters, getters, that kind of stuff. But what we can do as well, we can also create new objects, like I'm doing here. I am creating a brand new object, which is a process builder. With a process builder, I just feed it the bash. And this bash, I give it an arbitrary command. Well, long story short, if I redirect the input stream to an output stream and show it on my screen, I am allowed to basically call any function that is available on this Linux distro, on this machine, depending on how large the privileges of this user are, and I can just execute it. Let me show you that. So we know that this application runs on Heroku. So let's clear the screen and say, and let's get the environment variables. I will explain to you in a second what I'm doing. So what I'm doing is I'm taking that exploit header, and I'm substituting the word command for the word env. And env is nothing more than the command to get my environment variables. And this one, it's a curl request to a local host, but this one is not running on local host. No, this one is running on Heroku. So let's just go over there. Now let's remove the local host and put my Heroku instance on it just to spice things up. So if I do this, we see it executes, and it comes back with the environment variables of my Heroku system, because I'm just using an outdated version of Apache Struts 2. I didn't update. Okay, now you can say, like, the environment variables, how important is that? Well, I can see the Java options. Not that interesting. The Java home, this might be interesting. I actually know on this Java, or on this Heroku application, where my Java home is at that point. Okay, maybe I can do something with that later. But the point is, if I can call the env variable, I'm probably able to maybe create a file, delete a file, create a file with some content, basically create a script. If I can create a script today, maybe I can call it tomorrow or the day after. And, well, if I call it tomorrow, good luck with you finding out what actually happened, when it originated, what the actual problem was. Even if you have okay logging, but you're not physically monitoring these kind of things, it's quite hard to get to this point. Point is, I can call a lot of commands with this header just because you were using, or they were using, Apache Struts 2. And it is not because their code was donkey, or their code was not good enough. No, that was because they imported the wrong version of a dependency, or they didn't upgrade right away. So I have the Java home. Let's get back to that one later. Let's first get into, the presentation. Because if we patch this back to your application, say this is the jar in Spring Boot that you put into production, how much of that jar is actually your code? It's probably something like this. It's not much. I mean, the rest is Spring Boot and everything that Spring Boot includes, because the Spring Boot starter is basically an empty jar, or an empty jar with just a POM file in it, and it includes a whole bunch of stuff. And that is just the Spring stuff. And then comes everything that you include, like maybe some stuff from Apache and the Apache Commons libraries, or whatever you're using. And how do you pick these kind of dependencies? Do you actually look into how healthy they are? Do you take a look at how many maintainers there are? Are you maintaining that thing? Maybe you should. But if there is a dependency that is just done by one maintainer, it's quite a risk to have that into an enterprise level application, don't you think? Well, say I have a Spring Serverless application over here. We created this demo like I think 2 years ago, and at that point it was 222 lines of code. Not interesting. It was demo code. It was a lot of duplication. It was horrible. I wrote it, so yeah. However, it had 5 direct dependencies. And 5 direct dependencies, we know that dependencies pull in dependencies, pull in dependencies, pull in dependencies, come back to 54 dependencies in total. So 54 jars are there available in my class path and can theoretically be loaded into memory. That's how Java works. And I'm not responsible for only the 222 lines I wrote. I'm responsible for the whole jar and all its dependencies included. So how many lines of code do I actually put into production? At that point, it was like 460,000 something. So just a little bit shy of 500,000 lines of code. And if something goes wrong, either in my own custom code or the code I inherit from my dependencies, they will come back to me and my team, and I need to take responsibility. Because, hey, in the end, we're doing DevOps. If we didn't do DevOps, then somebody from the ops team was responsible, and they, again, referred it to me. But you get what I'm saying. And open source uses has exploded over the last decade. But we should think of open source application, open source packages, just as the same way as we do with our code. It's not by default insecure nor secure. It's in between, just like the code you and me write. We make mistakes. And we should update the code. And that's why attackers are targeting these open source packages. Because can you imagine if a large open source package has a vulnerability? Then people will just, well, basically they have a large pool of potential victims. So taking good care of the quality of your own code and making sure that you do code reviews, that is excellent. Don't get me wrong, you should do that. But that's just the beginning. This is the first part that's under the surface. And the total amount of packages in the last couple of years has exploded. I mean, you see here for different ecosystem how it went. Like an NPM is the clear winner. And well, I think it was mid-June 2019, they crossed that 1 million packages. But even the increase between January 2018 and 2019 for Maven Central is almost 100,000 packages. And they are on top of the other parts that were already there. If we look at the vulnerability identified since 2014, luckily between 2018 and 2019, it goes down. But still, it are a bunch of vulnerabilities that are known. And if they are known and published, they are not only available to you, but available to anybody. And in many cases, not so much the problem is the package that you actually include in your POM file. But that, again, that package includes another package deep under the surface. So it can be that several layers deep, say 5 layers deep, there is some weird marshalling library that has a deserialization issue. But are you aware? Maybe not. We asked open source maintainers in our yearly state of open source security research, like, how confident are you in your own security? And 63% says, well, okay-ish, kinda. But should we blindly trust kinda? Or not? But who is responsible for security? A lot of developers feel like it's not their responsibility. Like, hey, I'm just building the stuff. That's what I'm good at. I'm solving the puzzle. That's what my strongest part of the what I do is. Fair point. But still, we have to take care of, nowadays, we have to take care of scalability, maintainability, reusability, and all these abilities. And security should be one of them. And that's what the people believe. A lot of people believe that in software, developers need to take their fair share. It's still a shared responsibility between the security professionals and the operation folks and the developers. But think about it. If there is a problem, I have the ability to solve it, and I'm pulling packages, I'm creating code, and I'm solving the problem. However, I'm taking that code for a reason. It should be the right reason. It should not only because it's fast, or more importantly, because Stack Overflow told me so. It should be because you thought about it, not because, hey, it works, let's ship it. You should be conscious about these decisions. I'm here in a building, in a house, on the top floor, and I hope the people who built this thing, and not only the architect, but also the people who actually built this house, took their responsibility that they used the right material and the right way of doing it, that it doesn't collapse like under my feet. You know what I'm saying? That's the same with software. We should take responsibility. Not only we, but we should take a fair share. So let's hack. I showed you already that Java application. Now let's go back to that. So the Java application, let me just sign up for it. Let's go into the Java application and say, sign up. Let's use a password 123456 because I work at a security company. It's perfectly fine. So I sign up. Don't do this at home. No, don't save it in my 1Password. And what I can do, this is a to-do list. It's nothing really special, but I can create a to-do like eat pie. Let's be a little nerdy and give it a 1970 is good. It's like, I give it a high priority because, hey, it's already, it's almost 8 o'clock over here and I'm pretty hungry. If I create this, you'll see that the function eat pie is translated into eat and the ASCII representation of the pie sign. By that, I know that every title I put into the system, it goes to the native to ASCII function, which is part of the JDK. So I know that every symbol will be translated by the native to JDK, native to ASCII function, which is there. Keep that one in mind. What I can do as well here, I can upload files. I can upload zip files. And if I upload a zip file, I'm using a library to unzip these files. Now, why is that? Because Java doesn't have a clear unzip function. Java we can look into the zip entries, we can get the byte stream out, but we still have to recreate or create the file on the actual file system and put the byte stream in a nutshell. So what happens is a lot of people just use a library for that for a good reason. Either the library is from Spring or from somebody else, but there are a bunch of libraries that can do this. Well, if you use the wrong version of the library, some interesting things can happen. Remember this Java home I showed you? Well, let's use that one as well. What if my zip file looks like this? This is a zip file containing two files. The one is good.txt, which is just a plain text file. And the other one is a ... that path reversal I showed you earlier with that file thingy. /app/.jdk, which I got from the previous hack. I know that is the location where my JDK is on Heroku, /bin/native to ASCII. So what I'm trying to do is, I hope that this application or this library doesn't check the file name properly, doesn't do input validation on the name, and actually overrides the native to ASCII file by unzipping it. Let's try this. Let's upload the file, and I have the zip file over here. And if I upload it, I see that the good.txt is there in the public folder. So the unzipping worked. I know that the unpacking of the zip file worked. So let's see what happened. It doesn't matter what I put in. It doesn't matter what the priority is, because every title will be created and will be replaced by Muhaha Gotcha, because I overwrote the native to ASCII file, which is part of the JDK in this Heroku instance. So if I put something else in it, just put some gibberish in and give it a random date and a medium. Again, it will be connect to muhaha gotcha. Because I overwrote the native to ASCII file and basically it says echo muhaha gotcha. And that is because I was using the wrong version of a library. Interesting, isn't it? If I just update it to the later version because it was 1.12, and if I update it to 1.13, then it would all be okay because that version checks for path reversal exploits. So this one was already, just like all the other ones, it was already known, it was already disclosed, it was already fixed, and there was a new version out. But I wasn't aware. All right. So, fun fact. Say, in general, when you go to production, you are vulnerability free. How much time does it generally take for a vulnerability to be disclosed, or found and disclosed, basically? Just take a number in your head. It is about 2.5 years. That means that over time, as long as you're using that same product, people will just go around and just look at it and exploit it and look in the code more and more until they find something. And that just happens. But think about it, if you're working for instance, that government agency I told you, so I also worked for a couple of banks here in this country, and they tend to have software in production that nobody owns anymore because, hey, it's working there for so long and people are depending on it. However, nobody dares to touch it because so many people depend on it. Well, if it's outward facing, you should be, I suggest to take a look at it because there might be a vulnerability disclosed by now. Get me? So we basically had the second layer. That was our open source dependencies. But we're talking cloud native, so we need to put something in containers or, well, mimic the containers. So basically a Docker container or push it somewhere on Heroku, which basically puts it in a container. And by encapsulating it in a container, a lot of people think that by default you are safe because it's an encapsulation. It is another abstraction, so you just cannot just go through it. That is the wrong perception, unfortunately. So let's dive into Docker, for instance. I did a research late 2019 on Docker images. And what we did is we downloaded the 10 most commonly used Docker images from Docker Hub. Because mainly what you do is when you create a Docker image yourself or a container yourself, you start with a Docker file and it says from Ubuntu or from OpenJDK or from, well, you get me. We downloaded the 10 most commonly downloaded images and we scanned it for vulnerabilities, and this was the result. And of course, if I would do it today, the numbers will be different. The point is that all of these 10 had vulnerabilities. And for all of these vulnerabilities, we could, well, except for the Ubuntu one, because that's already the base image. But most of these images are based upon another image. Say the node image, for instance, was based upon, I think it was, at that time, it was a Debian Jessie image. And most of these vulnerabilities, so not all of these vulnerabilities, could be traced back to that base image Node was using. So I was just using the latest image because I didn't put a tag in. I thought the latest was good enough. It worked, ship it. You get me? However, with a full-blown operating system, do I actually need that? For my microservice with 3 endpoints, do I actually need a full-blown operating system? Probably not. And that operating system brings in a lot of binaries that might be risky, or they might have a vulnerability. And these vulnerabilities might not always be directly connected to your application or not directly connected to any of the paths. But think about it. Every security issue is not just a direct hit. Most of security issues is a connection between things that can go wrong and can be connected to each other. So it's so-called chain of attacks. And if one of these binaries can take place in that chain, then, well, it can go worse and worse and worse. Point is, what's not in your base image cannot harm you. So you should be aware of what you put into your in your container, because it is, again, something you depend on. We ask people, when do you scan your Docker images for operating system vulnerabilities? And a lot of people say, we don't. And how do you find out about new vulnerabilities in your deployed containers? And also a lot of people don't. So let's get into that Docker part. So I have this Java application. Well, let me see if this one is still running. It's not. Good. So I will create a Docker image of this application. And let me just say, see where this is. A Docker image, of course, is right back. So let's take a look at the Docker file. And I'm using a multi-stage build from Maven 3, and I actually, my end container, my final container will use a Tomcat container, Tomcat 8521. And it's a little bit outdated for a reason. So say Docker compose up -- build. So let's build this Docker image, and I actually rebuilt this thing that I have on Heroku in a Docker image, and I run it. Nothing more. I do some port forwarding, and let me see if that works. Creating the Java goof, yada yada. Hopefully I have everything cached because I tried it just before this presentation, and it should be cached to the end. Yes. Cool. So if I go to localhost 8080, I see the Tomcat, and if I go to /to-do list, well, for some reason it doesn't load the CSS, but it's that same welcome to my to-do list, which is the basic thing that we had just had. But we don't need to have this application. This application, it doesn't matter what application it is. The problem is not the application. The problem is the Docker image. Because this Docker image has an issue. It basically has this issue, an arbitrary code execution that is part of Tomcat that is used, this version of Tomcat that is used in this container. And the point is, I will highlight it for you. It was possible with this, I think it was possible to upload the JSP file to the server via a specially crafted request. This JSP could then request any code it contained would be executed by the server. So basically, I can upload JSP files that will, and I can insert code to do whatever I want. Well, there's an exploit. Let's go to the exploit DB. And basically, this exploit is in Python. And what it does, it creates this specially crafted request for me, and it has two payloads. The one payload is just a proof of concept, the POC, and it just outputs a lot of A's. Nothing really special, but just to check if it's there. The second one is the RCE, the remote code execution, and it basically creates a form for me. And in that form, I have a submit file. I have a field that I can submit, and then it calls the runtime and executes basically the thing. Interesting. Let's try if I can do that. If I go over here, I think over here, I don't have Python on my machine, so we created a Docker image that contains Python. So let me create that image just for a second, and I have the codes available, and I can actually execute those two exploits I just showed you. And again, this has nothing to do with the application, but because it's using Tomcat, and Tomcat exposes this problem. This takes a long time. It was faster when I was not streaming. Sorry for that. So, what I can do the first one is check. So if I do check, it basically puts that POC in, that POC.jsp. So let's see if that POC.jsp is there. So if I go to this thing and POC.jsp, without the to-do list, it's in the root. If I do that, you will see that we have these A's. Okay, interesting. So basically we say that this execution or this application is working. Well, let me show you that the next file is not yet there. So pwn.jsp, which I will call, is not yet here. But however, if I call that second option that I just showed you, that it inserts that JSP file with that that form and it actually executes that form, I have it on a shortcut over here that's at pwn. And it's uploading that web shell. Okay. So if I now go over here, I see that this is over here. So I can do something like, okay, cool. Who am I? Oh, cool, I'm root. Because in many cases, Docker images, if you're not calling a specific user, by default it runs as root. So that means I can create files, I can delete files, I can see the environment variables of this system. So I basically have my own created web shell because I'm using the wrong version or an outdated vulnerable version of a Docker image that I maybe created a Docker file like months ago or years ago. And hey, it still works. Let's use it. So I should be aware of that as well. And I should be scanning that on at least a regular basis. Interesting, right? So this has nothing to do with the application. This is yet another layer that can be influenced by any type of vulnerabilities. Then we have the fourth layer, and I don't have a thing for that. But that's, for instance, your Kubernetes and Terraform files. With your Kubernetes files, with the YAMLs, you can do a lot of things wrong, like improper configuration or misconfigured Kubernetes cluster can open up things are unfortunately run as root, etc., etc. So that is yet another and the last endpoint within the cloud native application security spectrum that can harm your application. And we should be aware of all four of these things. However, in most cases, we only look at the top of the iceberg, which is our code, and it's very important, but the other ones are just as important. But how should we solve this? Well, basically, it's three things: culture, process, and tooling. And these are equally important. Just throwing tooling doesn't help. Trust me. Let's go to culture and make a team culture, a company culture. Think about who are you working with? And in your team are different people with different strategies, with different KPIs. And developers, for instance, they want to, we think about making sure that all features are fully available. We want to code faster. We want to use interesting new frameworks or interesting new technologies. We are builders, like developers are builders by heart. A security person, they just want to keep it secure, not getting breached. If you, for instance, are failing and you are not able to deploy things, they're fine, because if it's not deployable, then it cannot harm you, right? If you look at the operations folks, they want to make sure that things are simply deployable, scalable, predictable, stable, and the availability. So if something goes wrong and in the middle of the night, maybe it automatically spins up again. These are the things that like typical operations folks think about. And then we have management. Management, they think about deliverables and making money. But that manager is breathing down my neck to make sure that I deliver that feature yesterday. Well, at least end of day. And by breathing down my neck so much, I'm trying to cut corners. I'm trying to make sure that I fix that KPI and that I can deliver. However, that is not good for the next KPI for the security folks. So if we all play along a little bit better, like if your manager gives you the time to get rid of your technical debt, read yourself into, educate yourself into what are common security vulnerabilities, because that is something you normally do not learn as much in university or whatever education you had. And as a developer, we should be aware of that, hey, it works is not good enough. Like a decade ago, we weren't aware of that things should be scalable, like horizontally and vertically. Nowadays, we are. It's in our head. It's branded in, and it should be the same with security. If we take care of that from the get-go, we make sure that we make secure decisions. We help the security folks, so it doesn't come back to us after 3 weeks. So playing along and seeing the importance of all of this is the essence. If that doesn't work, the rest will not work ever. Then we have process. Like, look at your process as how you develop your current software. How is your software development lifecycle nowadays? For instance, I can say like you should automate this in your CI pipeline. But if you don't have a CI pipeline, it doesn't make sense, does it? No, look at how you work, how the way you create software, and let's adapt that in such a way that you have, for instance, the tooling in that not doesn't block you, but maybe enables you. And I come back to that because that's where the tooling comes in. Okay? Like creating new process and just checking boxes doesn't work. But if you have tooling that supports your way of working, then you're at the right spot. If you're willing to do this, you pick the tooling to do this, then it's starting to get interesting. For instance, say this is your development lifecycle. Start coding on your local machine. Why not scan over there? If I scan over there, for instance, with the stuff I created or my team created, and you do a test on your local machine, and it doesn't only say like, hey, this package is doing something wrong, but also has the fix like, hey, if you update to the newer version, that is interesting. And I can already tackle that problem before it actually goes into my master branch. Same holds for your code, same holds for your Docker containers. If it's your repository, if it's there, why not connect your repository to a scanning tool that scans on a daily basis and actually pings you when something is wrong or when a new issue is found? When there's a new issue found, you want to know about it and act accordingly. Maybe it's not interesting for you, but maybe it is. But that's up to you. It's your context. It's the way you work. And sometimes you're okay with a certain level of vulnerabilities because they are not that harmful and you want to take the chance. Fine. But you probably do not want to get worse. Then your CI pipeline. Of course, within your CI pipeline, you should, if you have it, you should automate all these things and scan this stuff and scan your Docker containers before they go to production. But you're not done there. Most people stop over there, push it to production, and go back to what they were doing the rest of the day. No, before you go to production, for instance, monitor, like with Snyk, we can do a Snyk monitor. And I'm talking from my own pro product because I know how it works over there. Because at that point, everything is static. We know what the image is. We know what the dependency trees is. You know what the code is that goes into production. So basically, that's a static deploy. Why not scan that on a daily basis and actively ping you when something is wrong or there's something found? Then it's interesting and you can take measures if needed. So scan towards your whole development lifecycle. And a lot of people, you hear like shift left. That means as left as possible in this diagram, but this is a continuous cycle. So there is no left or right. It's continuous because, well, we tend to work agile. So picking the right tooling that fits your process, and I'm just calling some things out, that is essential to make sure that your all these attack surfaces from your code to your Kubernetes cluster, information is all secure and will not harm you if you don't know it. If you want to know more about secure coding or creating secure Docker containers, we have a bunch of stuff available on our blog at Snyk. Feel free to go over there and read it. Comment on it if you do or do not agree. Feel free. And that is basically the end of what I have to say. If you do have questions, feel free to put them out now. Throw them in the Discord, or if you come to these questions like tomorrow or the day after or like later today when I'm sleeping, feel free to ping me on Twitter or send me an email. Thank you so much for your attention.
Great. Thank you so much, Brian. It's a great presentation with lots of really awesome information. Really, really good. Does anybody have questions for Brian? Please feel free. I currently don't see anybody asking any questions on the dialogue. And if anybody wants to turn on your video and audio and ask questions directly, please do so. Introduce yourself here too. So yeah, seems like everybody is quiet today. Let's see. No one has questions?
Maybe they were so overpowered. I don't know.
Yeah. Yeah, we do have a comment from Kevin. Thanks, Kevin. That was really, really great. Very hands-on is key with security stuff. Thanks for this. So that's from Kevin.
Thank you, Kevin. I believe that doing this, like from a developer perspective, is the way it should be. Like I can go to all the theoretical stuff, but that's boring. I'm a developer. And getting confronted with these kind of issues, that is for me the interesting part. So thank you, appreciate it.
That's right. Okay, yeah, we have Bala Karan. Can you share the best practices present a while ago? So
I did a presentation about Java best practices. I'm not sure if that is what you mean. Basically, that is based upon the cheat sheet that is available on our blog, and I think I presented it. I'm not sure where I presented it. To be fair, might be Devnexus or something.
okay.
When I joined, it said it's being recorded. Where do we find record? That is something that Mary can answer.
Oh, okay. Yeah, that's right. That one, Angel, I will post it again, the link, which I did earlier. So let me post it again and just copy it over.
Quick question. This is Shashank. So the one that you have showed in IntelliJ, right? So you have a plugin on IntelliJ that you can scan out the project and see the recommendations and everything?
Yep. That is basically part of the Snyk plugin, and that does both the scanning for the open source problems that I showed you, for instance, with the struts hack, but also scans your custom code. It can scan your custom code and can find. It's not 100% true, of course, because there can always be false positives or false negatives, but it shows you where there are problems in your code. For instance, the path reversal or the XSS, or I have examples for SQL injection as well.
Ah, cool. Yeah.
These plugins are available on the marketplace for IntelliJ, but I didn't want to go too much into the product because that is for the product people. I was more for like, we need to be aware of this security stuff, and there are also plugins available probably from other vendors. Feel free to use them. It's about like making sure that you are aware that we should take care of this.
Yep.
Any more questions? It's a quiet crowd today.
It's lunch. Everybody's still eating.
It's probably still eating. Yeah, something. Yeah. And our weather is very nice today. Maybe folks are like a bit, taking time outside for walks or something. So, but otherwise,
and you should.
Yeah.
You should.
Exactly. Especially in Chicago, we are either too cold or too hot. To be like, perfect weather is very rare. It seems like a few days of the year that we get that. So, but yeah. But maybe let me ask you, Brian, since no one's asking. So if somebody is new, wanting to kind of start, how would you suggest them to start, to when you're coding and, we have so much to learn about. We need to learn about the language. We need to kind of, the application itself. And then, of course, security is always actually should be there and should be taught. But very often, too, I don't feel that there are enough emphasis, so to speak, when people start to learn, to code. But how would you suggest, right? I mean, this actually should become kind of like when you code, you need to pay attention to, best practices for against vulnerabilities. How would you suggest somebody new wanting to start? Is there a good place where they can reference the materials? Any good documentation?
There is some good documentation available. Of course, the folks from OWASP do a lot of good stuff. I know that one of our fellow Java champions, Jim Manico, wrote a book like our Ironclad Java Security a while back, which is an interesting one. Okay. I have it somewhere over there in my bookcase. That is an interesting one. Of course, on our blog, I try to specify, or I try to like show a lot of Java security snippets, like, hey, what should you think of? And I think I wrote that together with Jim Manico for instance, that best practices cheat sheet of 10 Java security best practices you should be aware of. These are all things that you I think should at least read and then take from it what is good for your application.
Oh, okay.
Thank you. I see it coming up in the Discord channel right away. Thank you, Shashank.
Oh, okay. Thanks.
That is one of the things, but that is just one thing. I would have a look at the OWASP. Know, for instance, what the OWASP currently the OS top 10 is. Like, what is cross-site scripting? What is SQL injection? What is path reversal? What are cross-site request forgery? Like, these kind of things, I still feel like they don't teach you these things in school.
Yes.
Which is like back in college, they taught me like how to program, how to use certain architectural patterns, but not so much what can go wrong. Hopefully they do it now. I'm not in school anymore for many years, so I hope that changed. But I still believe it's not yet there enough, and I think it is also a little bit of, how do you say that? Common sense. For instance, if you do code reviews, a lot of places, what we see is, and a lot of places I worked, is that, oh, we're at the end of the sprint and we need to make sure that this code is reviewed before production, and the demo is like tomorrow morning. Hey, new junior, can you please review my code? Here, you have 20 minutes. Just look at it. Is that fair? Like, of course, I'm exaggerating, but is that fair? And if something that you know of is very, say, security heavy, like authentication authorization, who do you pick to do your code reviews? Because I can make mistakes, you can make mistakes, but if I pick somebody who is keen on that, like one of the security folks, or that somebody that's already security minded, like, help me out, review stuff, but also if something goes wrong, help me out with how to solve these kind of things. So it's also a little bit of common sense, and not just satisfying the system, but also taking responsibility.
Sure. Thank you. That's great. Let's see. I guess don't see any more questions at this point. I also found the Ironclad Java book from O'Reilly, so I posted that link to our Discord.
Yeah.
So
I see it in the Discord channel. I think it's a very good book to
that's great.
start with.
That's awesome. Thank you. And I think I see Greg, our CJUG, usual suspect, has a question. What do you think about the Java Security Manager being removed?
Very good question. What was it? JEP 411, if I'm not mistaken. Yes, I'm in between. As in, the Java Security Manager is hard to use, is not well maintained. So from that point of view, I get it that they want to deprecate it. What I don't get is why they're just deprecating it and there's no alternative. I mean, with the Security Manager, you can do a bunch of things and make sure that accessibility to certain libraries is not possible, or, for instance, reflection is not possible, just to name a few of these things. It's very hard to do that in Security Manager, but at least that is possible. And stripping that out means, like, the one thing security-minded that we have, because nobody dared to touch it, you're stripping it out. That's how it feels to me. So I feel like, instead of stripping it out, make sure that there is a replacement for it that is easy to use, that can do pretty much at least the same thing, because even though it's just 1 or 2% that's using it, 1 or 2% of 10 million Java developers is still a lot of people, and might be a lot of critical applications. I don't think they're stopping it now for the right reasons. I do get the comments, because I read what the initial JEP was and what a few of the folks say, like, hey, it's outdated, it's there since, if I'm not mistaken, Java 1.2 or something like that, like ages ago. A lot of people don't know how to use it. Maybe it's time that we rewrote it, or we learned people how to use it, instead of just bluntly removing it. Long answer, because, and at the end I would say, don't do it, don't remove it.
Yeah, totally. All right.
Hope that answers your question, Greg.
Okay. Any more questions? Any from anyone? And of course, we can continue the conversations. If you think of something afterwards, go to the Discord channel and ask questions there. And I hope, Brian, you stay connected with us that way as well. So, and I will see you
Absolutely.
too. So,
yeah. Absolutely. I will stay connected there. I might not be responding like right away tonight, but I will definitely take a look at it, and I will stay connected within the Discord channel, of course.
Yeah. Thank you. Thanks, Brian.
All right.
Okay.
Thank you,
Yeah,
folks. Thanks for having
sounds
me.
good. Thank you. Yeah.